Hi students, in this video I'll be going through the 2022 O-Level Additional Mathematics Paper 2 question 4. Alright, so let's read the question. So a diagram shows a closed loop container designed in the shape of a cuboid. The rectangular base has dimension of x and 3x cm. The height of the container is h. So the volume of the container is 2000 cm cubed. Okay, show that the total surface area of the six faces of the container is 6x squared plus 16,000 over 3x. Okay, so now we want to show the surface area uh, and show that it can be given by this expression over here. Okay, so let's try to find an expression for the surface area. Okay, so the total surface area, so total surface area. Okay, let's call this A. Okay, so a total surface area would be the top and bottom face. Okay, so there will be two of it. All right, so 2 times, okay, the top and bottom face would be 3x times x, right? Okay, the area. Okay, then we'll plus, okay, the left and right faces. Okay, so the left face would be, left and right faces will be x by h cm. So once again, there will be two of it, so x times h. And then after that, we will have the back and front faces. Okay, so the back and front faces would be 3x times h. Okay, so plus 2 times 3x times h. Okay, so let's simplify this. So over here we have 3x squared times 2, so 6x squared. Then over here we have 2xh plus another 6xh. So that will give us 8xh. Okay, let's call this equation 1. Okay, if you look at the expression that they want us to show, it doesn't have the h, right? Okay, so this means that we need to do something in order to substitute away the h. And the info that we have not utilized yet would be the volume. Okay, so we are going to form an equation using the volume 2000 cm cubed, and then we'll make h the subject, and then we will be able to substitute the h away, and hopefully we'll be able to obtain this expression over here. Okay, so let's go ahead and do that. So volume equals to 2000 cm cubed. Okay, so the volume will be base times length times breadth times height, right? Okay, so 3x times x times h will be equals to 2000. Okay, so we have 3x squared times h is 2000, so h will be 2000 over 3x squared. Okay, so let's call this 2. Okay, so we're going to substitute 2 into 1. Okay, so substitute 2 into 1. Okay, so we'll get area equals to 6x squared plus 8x times 2000 over 3x squared. Right, so all we need to do is to simplify. So that's why 8 times this 2000 is going to give you that 16,000. Okay, x divided by 3x squared. So one of the x will cancel off and we'll be able to show the expression. Okay, so the expression for the area in terms of x would be 6x squared plus 16,000 over 3x. Okay, so we have successfully shown this already. Okay, so this is usually the common way to solve this kind of problem. You form an expression for the thing that they want you to find. In this case, the total surface area of the six faces. And then usually there will be two unknowns, two variables, x and in this case x and h. So we don't want the h, so we need to find some way to substitute away. Okay, and this and we can do so by making use of the other info inside the question. All right. Okay, let's look at part B of the question. Okay, in part B, they say that given that x can vary, find the value of x for which the total surface area. So in this case, the total surface area is A, right? It's stationary. So we know that for stationary A, it's either a maximum or minimum point, and at maximum or minimum points, the gradient is going to be 0. Okay, the gradient for the graph. Okay, if you draw out the graph for A. Okay, so in this case, dA dx is going to be equals to 0. Okay, so A is equals to 6x squared plus 16,000 over 3x. Okay, so we're going to put in a form suitable for differentiation. So it's going to be 16,000 over 3x to the power negative 1. You always remember the numbers don't move. Okay, so the 3 is at the bottom, just leave it at the bottom, bring up the x, and the power becomes -1. Okay, so let's do dA over dx. So you will get 12x. Okay, times first. Okay, so -16,000 over 3. Then reduce the power by 1. Okay, so you'll get 12x minus 16,000 over 3x squared. Okay, over here. Okay, so next one. So at the stationary value of a, dA dx is going to be equal to 0. So at stationary a, dA over dx equal to 0. So 12x minus 16,000 over 3x squared is going to be 0. Okay, so 12x equals to 16,000 over 3x squared. Okay, so we just cross multiply. Okay, multiply both sides by 3x squared. So you will get 36x cubed equals to 16,000. Alright, then we're going to divide by 36 and then we almost done, right? Okay, so what we need to do to find x will be to cube root this 16,000 over 36. So x will be cube root of 16,000 over 36. Okay, this one will give us an answer of 7.6314. Okay, we're going to round to 360, so 7.63. Okay, so this will be the value of x that will give us a stationary value for a. Okay, so this is how you do the question. So stationary value of a, then dA dx equals to 0. Alright, it's just like we want to find the stationary value for curve y equals to something something x, then we will put dy dx equals to 0. Okay, so it's the same idea. Okay, so last part is a common question frequently asked. Determine whether this value x gives a maximum or minimum value. So far we know that it gives a stationary value, but stationary value can be maximum or minimum, right? So how do we verify if it's a maximum or minimum? So we can either use the first derivative test or the second derivative test. Okay, so how do we decide? It's actually very easy. We just ask ourselves one question. Is it easy to differentiate the a dx one more time? So if it's easy, then we'll just find the 2a dx squared. So in this case, it's quite easy to differentiate one more time. So that's basically what we're going to do. Okay, so let's write down the a dx one more time. So the a dx is 12x minus 16,000 over 3x to the power -2. Okay, so we'll do the 2a over dx squared. So differentiate 12x, we're left with 12. Differentiate 16,000 over 3 times -2, so you get plus 32,000 over 3x to the power -3. Okay, so over here, okay, so basically now we have this 32,000 over 3x cubed. Okay, so 32,000 over 3x cubed. Okay, so we'll sub the x value inside the 7.6314, and we'll see whether the 2a dx squared is positive or negative. Right? So when x equals to 7.6314, the 2a over dx squared equals to 12 plus 32,000 over 3 times 7.6314 cubed. If you use the exact value for this, okay, you will be able to find that it's going to be actually equals to 84. Okay, calculate out 84. Okay, so the 2a dx squared is greater than 0. So if you recall, if the 2a dx squared is greater than 0, then this particular value of x of 7.6314 is going to give us a minimum value for a. Right? So let's conclude. So since the 2a over dx squared is greater than 0, x equals to 7.63 gives the minimum value for the total surface area. Okay, so overall, not a very difficult maxima and minima problem question. Okay, rather typical, and the expression is also not difficult to differentiate. Okay, so this is a question that most of you should be able to do well in. Right?